So I will do a pretty interesting stuff today, and I'm really excited about it because it really excites me. The topic really excites me. But let's do it in a old school fashion, and let's start in a natural way. And I will use this in an application. I thought to do the other way around so that I can show you the basic things, and I can give you the enough motivation. But I will start with a different way, and I will end with a beautiful problem and application, and that you may not have done very quickly without knowing linear algebra.
Hello, guys. Welcome to Cheenta School of Statistics and Data Science. We are a team of extremely passionate teachers, researchers, and statisticians from the top universities of India and USA. Our mission is to help you curve your career in statistics, data science, and machine learning. To book a trial class for your preparation courses of IIT MS, ISI MStat, and CMI MStat Data Science, check out the first link in the description below. If you're enjoying the video, show some love by liking the video and subscribing to the channel. We welcome you again to this passionate community of budding statisticians and data scientists. Let's enjoy the rest of the video. Stay tuned and stay blessed.
So first of all, if you focus on calculus, okay, what was the goal in calculus? In calculus, to understand a function, to curve a function, to understand the behavior of the function, we did what? We use derivatives, right, as a medium, because we did a lot of curve stretching stuff, right? We did a derivative, and we use that derivative equal to 0 to understand why it's becoming so. This means continuous differentiable function on R. This set of a function, I wrote it wrong. As that f dash of x is equal to 0, this set gives a pretty good notion about how the function is behaving. Right? We have seen this. Even we have seen this also the next step, okay, f double dash is equal to 0. So if you think deeply enough, if you try to connect things, so what exactly this is measuring? This is measuring that, what was those points? The points were either the maxima or minima. And like locally, which are the points x such that fx becomes constant? Around which points fx become constant? Also, you can think about this. There's also another set of points which are important. It's called, you have seen this, maybe this is important, that is called fixed points. Fixed points. This gives a pretty good information about the function. So we will try our best, to extrapolate that idea, that beautiful idea, to this linear transformation A. So linear transformation is nothing but a function from r to the power n to r to the power m. So we have seen that, with respect to the, with light, I hope all of you are confident now in solving this kind of equations. In the light of this ax curl is equal to b vector, ax vector is equal to b vector, we have seen out how A plays a big role. How it plays a big role. Like in terms of column space, row space, null space. These three spaces, we have seen how it plays a big role. But the next natural question is that, can we get some idea like this? Can we extrapolate the idea of this in this aspect of linear transformation, which is a function, okay, again? And that made you, question the fact that can we find, x such that fixed points in some sense, such that ax vector, can we find a point x vector such that after applying a, it belongs to the span of x vector. That means it's, even of a transformation, the x vector belongs to the span of x vector. That means, in the idea, in vector space sense, if you think of a line or a vector, the vector is not changing its position or its direction. We will see when we end the today's class. We will see why this was needed in much more depth. Okay, because this eigenvalues came from a different perspective, which you couldn't have guessed actually now. So vector does not change its direction. In advanced linear algebra, you will see, we will be trying to find a subspace which does not change its direction. Like the subspace is, after the transformation, the subspace is inside, it's inside, the subspace is going to the subspace. That's the idea. So you can say that the span, the subspace, is going to the subspace of this. You can say this. For which x vector this is happening. Why? Because in some sense, this captures the idea that, in some sense, it captures the idea that it's a fixed point in some sense. Okay. Or, it's becoming constant in some sense. Okay. That's the idea. It's this, eigen values are trying to capture. Just like we have tried for calculus. Okay, we have seen for calculus, and we'll see this gives a very beautiful understanding of how a matrix transforms the entire space. I hope all of you got the idea, guys. Did you understand, guys, the basic idea? You have any questions?